Hello everyone, welcome back. I'm Hellcat Diva, and today we have a Figure It Out episode where I use my Hellcat in a physics problem. So in a previous video, I was at Las Vegas Motor Speedway participating in a Laps for Charity event. Now, having grown up in Michigan, I thought about how cool it was to be able to be driving on a track in January without fearing for my life. Now, in Las Vegas, we rarely see real winter weather, but on occasion we will get snow. So as I was preparing for this video, I thought, what if we were on the track and we suddenly hit ice, assuming there was no coefficient of friction between the tires and the track? So today's Figure It Out question is, if Las Vegas Motor Speedway features a 20-degree banking angle between turns 3 and 4, and the radius of the curve is estimated to be 105 meters, what velocity is required to keep a car on the track if friction is absent? Now, to get started, the best way to begin to solve a physics problem is to draw a rough sketch. Using the legend on Google Maps and a map of the track, I estimated the radius to be about 105 meters. Next, I drew a diagram of the car on the embanked curve. The green block represents my car. I just mentioned the radius is an estimated 105 meters, and according to the LVMS website, the banking angle is 20 degrees. I should add this diagram is not drawn to scale. Next, I drew a force diagram. Now this is key because it's going to help you determine what equations to use. I should note that the banking angle theta, shown in red at 20 degrees, is the exact same as the angle theta, shown in orange with the curved arrows. Now here is a great place to pause the video and solve the problem on your own. Then come back to see how I solve the rest. This is a really great way to practice as well as prepare for tests. Now let's move on. So let's take a look at the weight of the car. We know that the weight is a force, which is the mass of the car times the acceleration due to gravity, and the force needed to counteract that weight is a normal force that is in the opposite direction. But since we are on an incline, the opposing force is the normal force times cosine theta. And do you remember the rule for cosine? It's adjacent over the hypotenuse. Next, we need to consider the centripetal force that is pointing inward across the red dotted line toward the orange dot at the middle of the diagram. Now, listen carefully to the words I just used. I said middle of the diagram. Technically, center of gravity isn't at a point that is half the length, half the width, and half the height of my car, but that is another lesson for another day. So back to centripetal force. Another way to visualize the centripetal force is to look overhead at the top diagram as the force going in the direction of the red arrow as the car moves around the curve shown in red. So the force opposing the centripetal force is the normal force times sine theta, because that is opposite over the hypotenuse. And if you remember the equation for centripetal force, it's mass times the velocity squared over the radius. Since we know sine theta over cosine theta is the equivalent of tangent theta, remember that? We can write the following equation. And since the normal force cancels out as well as the mass, the equation is reduced to sine theta over cosine theta, which is the same as saying tangent theta equals v squared over r times g. From here, we can solve for v squared, which is tangent theta times r times g. And taking the square root, we can find v, the velocity. From here, we can simply plug in our known variables. The tangent of 20 degrees is 0.364. The radius is 105 meters, and the acceleration due to gravity is 9.81 meters per second squared. That gives us 19.36 meters per second, which is 43.31 miles per hour. So let me know in the comments if your answer was similar. Also, let me know if there was something in a previous video that you would like to be converted into a real-world physics problem. So that's it for today, friends. If you want to take this journey with me, feel free to subscribe. And remember, keep the racing off of the streets and on the track. I'll see you next time.